All right. I think I think we are now live at 8 o'clock on a Wednesday. Of course, it's always going to be on a random day and time because I'm not good at planning these things. I haven't been around lately just because I've had a lot of stuff going on in my life that I needed to get sorted out. A lot of working on cars and fixing things up. But we are back here again today looking at more weird 3D printer stuff on AliExpress. But this stream is going to be hopefully a little different. See, I really would love you guys to just talk to me in the live stream chat because part of this live stream is going to be about trying to help y'all out. You see, 3D printers are a fickle thing and they can fail to produce the desired product for 1.5 million reasons, I'm sure. So if you have any questions, ask me a question and see. I'll try and see if I can help you fix your problem. Better yet, if you have a short video of the issue you are experiencing, you can send me a link to your issue with the video in the chat, and I will take a look at it really quick after vetting it, making sure it's family friendly. It's got to be, for this channel. And then I'll try and help you diagnose the issue and see if I can't help you fix your problem here on the live stream, or at the very least get you heading in the right direction. So we've got a few things to talk about because today's live stream is just kind of about whatever 3D printer parts we can find. We've talked about a lot of different things. We've talked about hot ends. We've talked about motherboards and stepper drivers and stepper motors. We've talked about linear rails. We've talked about a lot of different things. But I don't believe we've ever talked about these things. Trying to point in the right direction here. Food 3D printers, which is absolutely a thing. One of the things we're going to be talking about. Now, part of the beginning of the live stream here is just making sure everything is calibrated correctly. So you're about to hear a small motherboards and stepper drivers and stepper motors. We talked about linear rails. We've talked about a lot of different... All right, cool. So that was basically a little bit feedback there because I just wanted to make sure the live stream was functioning as intended. So I am just one guy doing this, but hopefully we'll go over some fun things to talk about. And on the last live stream that we did stuff on AliExpress where we were looking at things, I promised I would purchase some of those compression fittings that we were talking about that should fit on a standard Mark 8 hot end, which is basically on just about every sort of cheap Bowden style printer. Anything Creality is most likely a Mark 8 style hot end. And I'm pleased to announce that I have in fact received those compression fittings, and they do in fact work as intended. I have a video coming up about this. I was supposed to post it. Man, try saying that a few times fast. I was going to post it a few days ago, but life. That being said, we do have it. And I'm going to be posting a video, basically a short tug of war between a relatively decent pneumatic coupler and a compression fitting on a Capricorn Bowden tube, and they're going to wear away the Bowden tube in different ways, and you're going to see why I prefer one over the other, and kind of why compression fittings seem to do better in my testing than pneumatic couplers do. And we're not even going to worry about like Bowden collets, and because Bowden collets are just cheap pneumatic couplers that are just more of a pain to replace. That being said, let's kind of just jump into the whole situation we got going on here because we need to get this stream going. So, why don't we start with this? Pancakes. Pancakes. Seems like a simple thing to make. I like making pancakes. Heck, I like making waffles. Nothing better than a freshly made pancake or a Belgian waffle when you're waking up and having breakfast, but why not make your breakfast infinitely more complicated for no good reason other than just entertainment? So I've seen these floating around for a while, and I've actually kind of thought about getting one at one point too. I don't really know what the heck I would do with it other than just make silly doodles with pancake mix. Uh, you gotta wonder just how reliable these things are. Now, it's kind of funny, it's like, making a pancake 3D printer, I wonder. Now, this is a Delta, yeah, this is a Delta style printer, not your standard Cartesian. So, we've got a few different trademark characters here made in pancakes. Supposedly Nutella. I feel like I've seen someone make something Nutella based as well in a 3D printer. I honestly couldn't say, but we're just kind of going through here and seeing what it is. Because, I mean, like, okay, if you're doing some sort of funny fundraiser event or something like that, I could totally see this being, like, one of those things people come in and be like, oh, cool, you can make a pancake look like anything. I'd probably just make a bunch of pancake memes, maybe like a Shrek or something, and just toss it at people like, here's your food. Just look at it, it's like, why is it Shrek? And just be like, don't overthink it. But memes aside, yeah, pancakes. These seem to be really popular. I'm just starting to wonder how thick can you make a pancake on one of these things? It doesn't really say. Now, the Delta printer they're showing has a pretty decent Z height, but I doubt you're going to make any sort of pancake go that tall. So, I mean, if we look at, okay, usage pancake printing, build size 100 by 100 by, okay, 13 millimeters. So, despite the actual physical size, you're not getting very thick on this pancake 3D printer. Now, machine size, working temperature. This has got to be the lowest temperature extruding filament I've ever seen. No, but clearly it's using a Bowden tube to feed the pancake mix down to what looks like kind of like a needle, if I had to guess. And it's just going on hopefully a non-stick plate. I don't know how 3D printing is going to work if you have to spray something like PAM anti-stick spray. And I wonder if these are machine washable as well. Questions you don't really think about to ask yourself when it comes to a 3D printer. Is your 3D printer build plate machine washable? Maybe. Only time will tell. I mean, that looks like a Teflon pan, which, okay. If that's a Teflon pan, how good? That's a non-stick surface. So you got to ask yourself, does the first layer of pancake mix need something to help the stick? Or do you still start out with the idea of like non-stick because it's Teflon? Do you have to use some sort of first layer adhesion removal agent, kind of like when you print PETG on something and you put a little bit of, I think it's people use sometimes, I believe sometimes people use like isopropyl alcohol or something, and it kind of separates the first layer. What goes into this? I wonder, because all your standard 3D printer knowledge kind of goes out the window when you're printing pancakes. And all I'm really serving to do with this is really make myself quite hungry. But that brings me to today's themed drink, which, red. It's red. Good old Gatorade. You gotta have something to drink when doing the live stream when we're just talking nonstop. So, yeah, we're starting out with something funny, something silly. But I gotta wonder, like, okay, this looks like it's built to be from the ground, almost from the ground up, a pancake 3D printer. I want to know if this thing is actually based on a real Delta printer that's just like heavily modified to make pancakes. I'm also wondering if pancakes, do you have to use a certain pancake mix? There's a lot of questions that don't have a lot of answers here, and I feel like if I ever did have like a Patreon or something, I would probably save up to get a Pancake 3D printer and then do something silly with it and maybe like donate it to a local high school or something like that so that they can do something with 3D printers and pancakes. Couldn't tell you, but no feedback on this particular printer. So whoever's buying this pancake printer is going in blind. This is the first, like, what looks to be purpose-made pancake printer that I've seen. But this is yet again just one of several things we're going to be looking at. Oh my gosh, hold on a second. Shipping $200. Woo! Man, that Suez Canal has messed things up hardcore. Oh my goodness, $200 to ship this. And we're also still starting at after discounts, it's only $915. What a steal. Yeah, I don't know if I could be on board with spending that much money to make pancakes. But let's move on to something a little more relevant to everything. So my friend actually got an SLA printer, otherwise known as a resin printer, and he got the Lagoo Mars 2 Pro. Now, Lagoo is pretty well known. They're pretty decent. We have yet to actually use it. We need to buy some resin. Now, some of you that have been watching my videos will know that I've recently worked with epoxy resin in a 3D printed 3-piece mold. Now, people have been wanting to see an update to that video and see whatever happened to that. I will be having an update video coming up for that relatively soon. Let's just say that for right now, things didn't really go according to plan. I'm thinking I'll need a different type of resin to use and probably a different type of material to make the mold from. But that will be in said upcoming video. So SLA printers are pretty interesting. You know, it fills up with resin in the reservoir and then it uses, I believe, UV light or something like that to cure the resin as it's coming out. So I'm just kind of, yeah, UV light. So this is one of those things where we want to try, but we want to do it in a well-ventilated room just because if you don't do it in a well-ventilated room, that resin can be a bit... what's the word? It's some resins have a lot of VOCs, volatile organic compounds, or something like that. I can't remember the exact acronym. There we go. Brain fart. But we'll actually be having some videos on this pretty soon. Lagoo, from what I've seen, makes some pretty good stuff. We have yet to use it. Clearly, we're using a linear rail on the Z-axis, and then it kind of builds... It goes upwards in kind of the same fashion, but I think... Yeah, I think it starts all the way down here, and then it moves upwards, and we were just working with some sort of product. One of my friends who does a lot of research and development at a facility that works on nuclear protection equipment was showing me a part that they had commissioned, and I believe it was a UV cured SLA print, which is kind of interesting. It's almost like it might as well have been an FDM printed part, almost like it, but it was almost like it was kind of like post-processed, like it was sanded or something like that. I wish I had the part on hand to show you. It's just a little little story from what I've been dealing with in terms of something like this. So one of the ideas we had when it comes to making a mold that we pour resin into is that when you make a mold of anything, especially a 3D printed mold, the resin or silicone or whatever you pour into that mold is going to show the shape of everything in the mold. And that includes all the layer lines. Layer lines, it's okay. You print it in anything FDM, layer lines are going to be everywhere. all over on your mold in every single mold. So one thing you can do is you could print it in ABS and then use a technique called vapor smoothing. And that would allow you to get a very like shiny, smooth surface. And I actually tried some vapor smoothing, but I actually ran out of acetone and I didn't have a metal pot that had a lid that fit perfectly. So I don't think my vapor smoothing experiment went quite the way I would have wanted it to go. So I'm going to try it again. I'm going to hop over to like, what you call it. It's not Salvation Army, but Goodwill. Yeah, there's a Goodwill not too far away that I can probably just buy like a used pot with a lid. That way I'm not, sacrificing something new that I'm going to pour acetone into and vapor smooth that. Now, that was the idea. The problem is with any sort of solid mold is resin is going to also harden and become a solid. So how do you remove the solid from the solid if it's like a perfect mold? It's a perfect cast. Well, that's where we come into problems. Typically, a mold is made from something flexible like silicone. Now, I have a bunch of silicone, and it's all Shore 20A, which the Shore 20 ratings, so Shore is a rating of kind of like a stiffness, firmness of a material that's flexible like silicone, and Shore 20 is pretty low. If you ever looked at a material such as Ninjaflex, and why don't we just pull some up just for some reference, because Ninjaflex is Shore 85. We're just going to let this load up real quick, and then I'll bring it into view. So this is Ninjaflex. This stuff is like basically wet spaghetti. And not a whole lot going on in terms of pictures here, but so Ninjaflex Shore 85A. It's basically wet spaghetti. It's a pain in the butt to print without a direct drive, because it's literally, take this right here. This is basically how Ninjaflex works. So Ninjaflex being Shore 85, the higher the number, closer to 100, the harder something is. So you can imagine the silicone that I was using, which is Shore 20A, is even more flippity-floppity. It's just kind of like, kind of just wiggles about in some parts that, because it's a three-piece mold, it's a pretty complicated mold. And because of that, Shore 20A is just way too flexible for what I'm trying to do. So I was thinking about trying to get some Ninjaflex and printing my 3D mold out of this stuff. The only problem is there would absolutely be layer lines in the resin mold, or in the resin cast that I would make from the mold. You can't really vapor smooth this stuff like you could ABS. I've basically designed my mold more or less like as if it was going to be injection molded. There's certain things like draft angles and such that I didn't really implement that may make the idea of using an ABS mold more viable. That being said, I have not done so. It took me a while to come up with the three-piece mold as it is, but it is making some progress, and the goal is to be able to somewhat on scale mass produce something that I print a lot of. So one thing that we were thinking of is instead of using Ninjaflex on an FDM printer, because we can't vapor smooth it to get rid of those layer lines, maybe what we could do is use an SLA printer such as the Lagoo Mars to make parts of the mold out of flexible UV hardening resin, which there are absolutely resins that are indeed flexible. How flexible? Well, I'm not really sure. Like I said, we have yet to actually use this particular product. The one issue we've run into is the mold that I am making is rather large, and we don't think it's actually going to fit in the build surface of the Mars. Now, I think there's one called the Lagoo Jupiter that is much bigger and probably will have the build surface we need, but As you can see, I think the pool of resin stays down here, and as it lifts up, we've got the UV lights that harden it in a particular way, and it goes layer by layer, much like any other 3D printer. That being said, so our idea was resin printers are extremely high detail. They don't have nearly as visible layer lines as your standard FDM printer would. So, if we take the design that I want to make, print it in a resin printer in very high detail, going nice and slow, and do so with a flexible UV resin, I might be able to make a mold that is flexible that I can then use to make casts of a thing that I usually print. Now, the things that I print take approximately 18 hours to print, and there's tiny variations between each print. But if I make a mold that I can pour resin into, then that might not be a problem. There's other issues we've come across with the resin we chose, but we only got like basically a sample size to work with to see if it was something we wanted to work with at all. And there were some issues with the resin itself, not necessarily being as hard of a substance as we were expecting it to be. It takes 72 hours to harden, but maybe we might have to go a different route with that. But this is our thought process for what we're doing so far. So we will be having videos at some point involving this printer. Now, this printer belongs to a friend of mine who's currently feeling a bit under the weather, so we won't be getting to that anytime soon. But it is definitely in the works for something upcoming. Now then, we're going to move on to another subject because I think this one's quite interesting. Filament creation by using pellets. So, you may have seen a number of people on YouTube try and recycle their 3D printed parts by grinding them down into tiny pellets and then re-extruding them to a 1.75 millimeter diameter filament. Those machines that do that are not cheap, and having good reliability out of those things is also something that's feels more like an art than it is a science. But these are the machines that do that sort of thing. So I figured it'd be worth talking about it. Now, a lot of times you can't just use 100% recycled filament because whatever it is, whether it's just excess supports, failed prints, things like that, you want to make sure it is all the same exact material. So if it was white ABS from Hatchbox, you only want to extrude that all together. You don't want to mix that with like black ABS from Overture, sort of. Everyone's mixture on every sort of formulation, even if it's the same material, PLS, ABS, or PLA, ABS, etc. Everyone's got a different formula for that. So you want to kind of keep the consistency there, but then you also have to grind it down into really tiny, tiny pellets. Because if you don't, it's not going to extrude properly. And then on top of that, the pellets that you're going to grind are going to be jagged, and they're not going to feed very well. So the common practice in the industrial settings is to mix a certain amount of recycled bits of plastic with virgin plastic. In other words, plastic that has yet to ever be extruded into a filament. And by doing that, you can still recycle all of your old filament, but it'll be much more reliable coming out. You'll just be mixing new unmade filament with the pellets that make the filament with it. That seems to be the more standard approach to going into things. Even when you're just recycling your general products and such, it's very, very unlikely that any recycled plastic is going to be 100% recycled, because in the manufacturing process of plastic anythings, breaking down plastic from its used form that was previously made into something back into something that can be used to be made again, usually doesn't come out quite as nice. So they mix it with virgin plastics. And these are the machines that, at least some machines that you can get on AliExpress that are cheap enough that if you really wanted to try it, you could. So this thing right here would be the thing that you put those pellets into. It goes into this little hopper right here, and then it heats everything up, and then kind of like, kind of like an, not an auger, well, maybe an auger, or maybe this is a better example. You ever seen a vending machine? How it's got those spirals, and then when it twists, it pushes the thing you've ordered from the vending machine forward. It's kind of something like that. It's like a screw that goes in here that pushes that little bits of plastic together and then kind of crunches it and then melts it, and then it comes out of this end. And that's how you get a, I want to say, a cylindrical shape of filament coming out. But then it also has to be winded up at the same time. Now, the complicated part of these things is getting it to wind at the appropriate rate. That's why you've got like these little sensors right here that measure the diameter of the filament, because as it's coming out, being re-extruded out of this machine, it's not coming out perfectly uniform. Its diameter can be a little bigger or smaller than what's necessary. And you can modify the diameter of that filament by adjusting the speed in which the winding process is done. So typically it's extruded and it goes down into a droop, and that bottom part of the droop is where the diameter is measured. And then coming back up to the winder, if it's too thin, it'll slow down the winding, and if it's too thick, it'll speed up the winding, and that'll help like stretch, or the opposite of stretch, that filaments as it comes out, hopefully getting you a relatively consistent diameter. I mean, that's how these things are, in theory, supposed to work, but the reality is a lot of these things are very finicky, and they don't exactly work the way you might imagine. It's not necessarily a simple thing to get running, and at $873, it's a lot of money to spend. Currently, most hobbyists will find that it's just not worth the money to recycle their plastic, because it's a lot of money, and you would need a lot of plastic to really justify it. You'll see these things more commonly in your local maker spaces, where people will come together and collaborate on things. I've actually got a makerspace I've wanted to go to not far from where I'm at, and see if I can't help contribute to the 3D printing area. But there's more than one way to go about this process. And ooh, we got some better pictures. It's basically the same machine. Got some better pictures. Ooh, this one's got some more to it than before. So again, this is where the plastic comes in, and then we've got we got a dial gauge up here, and that's going to tell you your thickness, and that's in between two little V-rollers, or maybe not even V-rollers, two gears, not even gears, I'm sorry, more like idler bearings, that when they separate and go up and down, it's going to move that needle and tell you just how thick the diameter of that filament is coming in, and that is apparently, it looks like it's situated in such a way that it works in tandem with something that actuates up and down that will signal to the roller here whether to speed up or slow down in the manner we were previously describing. So that's interesting. Water cooling tractor. Okay, this is interesting. Stepping motor is used to ensure stable traction speed. So online measurement function, a variety of cooling combinations can be chosen. We can provide the best solution. Very interesting. So, I mean, there's definitely different machines out there that do these things, and there are ones out there that are much more refined and that are much more suited to aiming at Not the average user, but more of an industry that's looking to reduce their waste that makes a lot of these things. I wouldn't be surprised if some bigger manufacturers like Prusa, for instance, they make a lot of filament. A lot of their printers have 3D printed parts on them. It's probably things that have supports or failed prints that need to be remade. And they print at such a scale that you would probably see it be reasonable to recycle that filament. That is ultimately the dream, right? You print whatever it is you want to print, the supports you grind back down and turn into more filament to print with. It would be a zero waste industry if we could all do that. But much like 3D printers were when we first started, they're not really at that point where these sorts of machines in this part of the industry are all that affordable. You can imagine back when 3D printing first started, I got a video of an old 3D printer from MakerBot, and at the time it was several $1,000s. But if you were to look at it now, you'd be like, wow, this thing's got to be maybe worth $50. We've come a long way, and the technology to re-extrude filament that's been made from waste plastic is definitely on its way in. It's just going to take a little time to have machines that can do it reliably enough for your average user to use it and get decent enough results and be priced at such a price point that it makes it justifiable. But that's interesting, I think. But let's move on to one of the things from the previous live stream. So I was talking about that I got the compression fittings that should fit and that do fit on a standard Mark 8 hot end, which those threads turn out to be 1/8 inch national pipe thread, or actually I think it's British. It's a British specification. Either way, it's a 1/8 inch thread, and it is a tapered thread, so it could very well be National Pipe Thread NPT, or it could be British Spec Pipe Thread. I forget which one it is exactly, but the combination you see right here, fit outer diameter of 4 millimeters. That's for this part up here. So if you size it up for this part right here, and this is critical, it needs to be a single ferrule design. A dual ferrule design, I've not tested. I don't see any possible reason why that would be better in this particular scenario than a single ferrule design. So Bowden tubes, usually the outer diameter is 4 millimeters. So that's why you would choose that. And then these threads being, if we're going with 1/8 inch tapered, which would be, here it is, BSP, British Spec Pipe or something like that. Very similar to National Pipe Thread. So these would be what's turning and screwing into your hot end. So they fit perfectly. They do just as good a job as ever. And if you get these should fit on any sort of hot end or extruder that uses a standard pneumatic coupler that you've seen for anything from Creality to the generic extruders or V6 hot ends that use threads of any sort. They're typically these 1/8 inch threads. So for about $4.50 to $5, you can get 5 of these, and you really only need the one. But I would recommend getting extra brass ferrules, just in case you need to redo it for any particular reason. But upcoming video on that coming soon, so that should be fun. The tug of war test, I've posted pictures of some of the results on my YouTube channel's community page, and you can see the difference in the wear patterns of pushing and pulling with a lot of force on both a pneumatic coupler and a compression fitting, and you'll see why one, I think, is better than the other, especially in a continuously running setting. So that's just something I wanted to address right here. Now, there is something I was going to do. So I know a lot of people, they look at these things and they don't necessarily want to buy something from a Chinese website and wait a month for it to get there and yada yada yada. So what I was probably going to do is, um, for people who want to support the channel, I was thinking about importing a bunch of these, and then instead of doing something like selling a shirt, like all these other YouTube channels do, I want to sell something that's actually useful to someone. I want to get a bunch of these, and if you want to support the channel and donate in some way, uh, I'll have things like that or other things that, for instance, I've personally tested and verified work really well, and have those as things that you can get to support the channel. Um, Everything from the wing nut design for the bed leveling system to the compression fittings that I've found that work. Why buy a shirt? No one cares about a shirt. What you do want is something that's going to make your experience with 3D printing a heck of a lot more enjoyable. So that's what I've been planning on doing is getting these and importing them. At some point, what I might do is just throw them on Amazon or something like that. So that way it's much easier for people to access them. I really do think these are the way to go. I've never looked back once I've installed them. And now that we have a set that has been sourced that will absolutely fit on standard parts without any modification, I think we're golden. We're ready to go to get these things out to people so that we can show that Bowden tubes are not nearly as fussy as they need to be, because Bowden tube setups are still very good in my opinion. The separation of the hot end from the extruder makes maintenance a breeze, and quite frankly, it's a more reliable setup in my opinion just because the parts are separated. Um, so we got that kind of going on here. So that is something I wanted to look at. So at this point, we've talked about a few different things on the live stream, and I kind of want to go into some other things here. But given that this is kind of an odd time of the day and time of the week to do a live stream, we haven't got a whole lot of people in here today, which is okay. That happens. I'm not really known for my live streams or anything like that. But at some point, we're going to get that all sorted out. Let me see. Here we go. I want to look up the Lagoo Saturn, because this is the 3D printer that we wanted to get. It's a bit more expensive than the Mars 2 Pro, but it is a higher resolution and it is a much bigger printer. So the Lagoo Saturn is also a resin printer. It's just basically a really big one. So this one, it's a rectangular build surface, so it's not going to be square like an Ender 3 or anything like that, but you can still definitely fit a bunch of stuff in there. This one is the one we wanted to go with. So we got, on this one, given the size, yeah, it makes sense to have two Z-axis lead screws, or, sorry, one Z-axis lead screw, but two linear rails. I wonder if they use genuine Highwind rails or not. I don't see any Highwind branding on these linear rails, so my guess is that these are probably generic linear rails, which, you know, at this price point, I'm not really surprised. Still, linear rails are a much better option for precision than V-slot rollers in general. But again, we have yet to actually use one of these things, and I am looking forward to it. Many videos to come. But with that being said, we've talked about the various subjects that I wanted to go over today, because I figured I don't have much going on today anyway, and I like to ramble. But given the fact that this was kind of an impromptu, random live stream on the middle of a weekday, kind of at night when some people are more likely to be heading to bed, I'm not surprised that this live stream wasn't so very lively in the chat, but that's okay. For future note, if anyone's watching, if you want to throw up some, or if you want to take some videos of any 3D printer stuff that you have personally going on, I'd be happy to feature it on the live stream as long as it's family friendly. If you have any 3D printer issues that you want help getting diagnosed, make a video of that and I will help you try and diagnose it here on the live stream so that we can all learn together. And if you have any weird 3D printer parts or information you want to toss at us for the next live stream, by all means, I would love to see and hear about it. So, with that said, we're going to go ahead and end the live stream here. And hopefully next time I'll have a much better prepared situation in terms of doing the live stream, probably on a weekend. I know I've said that before, but one of these days I'll get that right. Anywho, for all of you who are watching this after the fact, which most people do, thanks for dropping by, and hopefully I will catch you guys on an actual live stream next time you come on by.